Do you remember having to use stopwatches, thermometers, and other instruments in chemistry and physics labs? Personally, I've spent hours timing toy cars, measuring the temperatures of chemical reactions, and more. Being forced to manually collect and analyze data in experiments is tedious, time-consuming, and often leads to significant human error. Our device, LabSense, expedites this process of collecting and analyzing lab data by replacing manual techniques with electronic sensors. LabSense is basically a network of sensors, namely an accelerometer, a temperature sensor, and a color sensor. The accelerometer enables a student to measure speed and acceleration values without the need of a stopwatch or other error-prone devices. The digital temperature sensor eliminates the need for awkward attempts at reading thermometer values. The color sensor provides information on color changes in specific chemistry experiments, such as acid-base titrations. The values from these sensors are conveyed onto the online platform ThingSpeak, so that it is easy for students to view and analyze the collected data, as well as compare their values with those of their classmates. For example, instead of having to record and graph measured values by hand, ThingSpeak obtains and graphs the data from LabSense during the experiment, saving students significant time. The target audience for LabSense is chemistry and physics labs at high schools and colleges. LabSense will prevent schools from having to buy numerous measuring instruments, such as stopwatches and thermometers, for every laboratory classroom. As mentioned before, LabSense will save time for students and teachers, as results will be measured and plotted quickly and accurately. LabSense also eliminates a lot of human error from experiments, as students will no longer be responsible for manually gathering results. Overall, LabSense is an all-in-one device that is extremely useful for many scientific experiments. High schools and colleges are in need of an upgrade from old measuring techniques, and LabSense fills this need effectively. In the following portion of the video, we will demonstrate LabSense. As you can see, we encased our project within a silver wooden frame with a metal top. The top portion has holes to expose the color sensor and the calibration button for the accelerometer. Furthermore, the temperature sensor is attached to the side of the case and can be neatly wrapped around two protruding screws. The case also has wheels for setups in physics labs with the accelerometer. Finally, the circuit boards are surrounded by cushioning foam, and the metal piece can be slid out to allow easy access to the circuit. Here we show the calibration function of LabSense for the accelerometer. Before being calibrated, the accelerometer was consistently reading values of 6 meters per second squared while at rest. However, as you can see, after the calibration button was pressed, the stationary values were adjusted to 0 as they should be. In addition, this video segment shows the approximately 20-second delay between values being plotted onto ThingSpeak. Next, we demonstrate the accelerometer readings as the device is rolled back and forth. Due to the acceleration generated from this rolling, values of 1 meter per second squared are recorded and plotted onto ThingSpeak. To accomplish this, our code calculates the total magnitude of the acceleration in the x, y, and z directions. However, in this case, only the acceleration in the x direction will have a value. In this portion of the video, we demonstrate the readings from the temperature sensor being plotted onto ThingSpeak. As you can see, we have a cup of ice water and hot coffee to test the sensor with. While the sensor was in neither liquid, it recorded temperatures of 25 degrees Celsius, which was the temperature of the room. However, after the sensor was placed in the ice water, the temperatures began to plummet, dropping below 10 degrees Celsius. Then, after the sensor was placed in the coffee, the temperatures quickly rose, reaching over 50 degrees Celsius. This temperature sensor will accurately measure values from negative 55 to positive 125 degrees Celsius. In this final portion of the video, we demonstrate the readings from the color sensor being plotted onto ThingSpeak. The color sensor measures RGB color values along with lux, or light intensity. Furthermore, the RGB values are scaled in our code to have a maximum possible value of 255, in alignment with a typical color scale. Initially, when no light was shined onto the sensor, the plotted values were very low. However, when we shined a green light onto the color sensor, all 4 values increased significantly as the sensor recognized and measured the light. Additionally, the G value was much larger than the R and B values for this green light, reaching nearly 100, while the others only increased to approximately 50. Overall, LabSense is an all-in-one device replacing manual data collection techniques in physics and chemistry labs with electronic sensors.